Hello dear friends of Retro Photo House channel. My channel is dedicated for Soviet Russian prime lenses, adjustment, cleaning, adapting and so on. So I just decided to record another tutorial because people very often are asking how to adapt HELIOS 44m-4 prime Russian lens to Nikon cameras. But so there are so many videos over internet explaining how to do that, but all of them has one flaw. They are advising you to put some spacer ring under the rear optical block or under rear optical element, and it will work. Of course it will work, but by doing this you will change the optical schema of this lens F, and it will lead with no doubt to image quality deterioration. So I just want to show you how to adapt this great lens to Nikon cameras without changing optical schema. So basically this lens has a M42 thread mount standard for Zenith cameras. So to explain, and in normal conditions, for example, if you just will take the Nikon adapter, put it onto your lens, and then put it onto your camera, Nikon camera, like this, it will focus only to up to 4 meters, no longer. So why it's so? To understand this, we need to just a little bit of theory. The theory show us following. We need to understand what does it mean flange focal distance. So here is our lens, for example, it is this HELIOS 44m4, okay, and this is lens mount, this surface, and here it's a film or sensor plane inside the camera. So flange focal distance is a distance between lens mount, this surface, and plane of film or sensor. Okay, so in all M42 lenses, this distance is equal to 45.5 millimeters. So it means that at that distance, image rendered by the lens will be completely crisp and net, projected to this plane. Okay, so now if we take our Nikon camera, it has also its own standard. So here you may see the shutter and then the sensor plane. So here let's take in this way our camera. Okay, so this distance in Nikon cameras is equal to 46.5 millimeters. So there is 1 millimeter of difference. So if we will take our HELIOS or whatever else M42 standard lens and put it into camera, put it onto Nikon camera, it will focus not here on the sensor, but it will focus here, because this distance of our M42 lens is shorter by 1 millimeter. So it will focus our image here, but we need it to be crisp here. So, and it will lead to the fact that you will not be able to focus to infinity or even at 10 meters. Okay, so our aim and our goal is to make the, let's say, all optical block inside the HELIOS lens closer, in order to be in order if they the in order lens should be focusing here but not here. So, but there is another thing which even make things worse, because if you take the adapter, okay, adapter, it has its own thickness, and here we have 0.9 millimeters. So if we put the adapter onto the lens, now now we need to compensate not 1 millimeter but 1.9 millimeters, because we need to take into consideration the thickness of adapter. Okay, so it's quite quite important job to compensate it, because there is no so much space, but we will try to find it. So first of all, we need to cut the adapter. Here it has 0.9 millimeters, and by using turning latte I cut the adapter and it becomes 0.5 millimeters. So we have gained 0.4 millimeters of total 1.9 that we need. So it's the first step. Okay, then if you remove the back cover of the lens, let's remove it. This back, it has also its own thickness. It makes 3.3 millimeters. Okay, the thickness. So the second step we need to cut also this rear back part of this lens, using of course our turning latte. So it is already done. I prepared it in advance to show you, and it allows us to gain, now this, it has 2.9 millimeters. Okay, so we have cut here 0.5 millimeters of height. So here at this adapter we have gained 0.4, and here also we have gained 0.4. So we have compensated already 0.8 millimeters of our distance that we need. Okay, so there is another point I want to show you. If you put the lens, if you put the cutted back cover onto its place, and then you will screw the cutted adapter also, it will lead to some unpleasant thing. If we will put our lens in this position, very often the scale will be not on the top of the lens, but on the side or even on the bottom. So of course it's not very proper way to use the lens, and it's difficult to see the aperture values or distance value. So it's quite annoying thing. So to compensate these kind of things, what I do, I just make the holes and I put the screws on it. I not screw the adapter in, but you see I've cut the thread here, so you cannot screw the adapter, it's not screwing in, but you fix the adapter to the back of the lens with the screws here. I will show you how it looks like. So here we have our, now we can put it correctly like this. So here are the holes, and we just put the little drive screws on their places. And we now see that it's solid construction, and if we will put the lens on the body, camera body, you will see that the scales are okay. Let's take our Nikon camera. So, and when we put it, so you see the scale, aperture values and distance values are at their place. So we have fixed this problem. But it is not finished, our work. We still need to compensate 1.1 millimeters of distance. Okay. To do this, you just need to make some work inside the lens body. Let's remove front decorative ring. Just one moment, because I just put the wrong screw into the wrong hole. I need to readjust it here in this position. So we're removing the front ring. Then you need to remove this part with the filter thread. There are 3 little screws inside. we need to remove them. Then there is very interesting thing. You may see here 1, 2 and 3 screws. These screws are holding together external focusing ring with internal, in brass you see, with internal thread ring. So basically this ring, there is a stops here. One stop and another stop. So it's like a limiting, there are limiting grooves not allowing to lens to be turned more than in this side and screw it in more than this position. So now what we need to do, we just focus our lens to infinity, okay? Then you need to remove this ring. You see the blocking, and there you can see also the blocking pin. So this ring does not allow to this brass ring to turn more, but there is some tricky thing here. You remember this ring was in this position. So it cannot normally move more to infinity. And what we need, that complete optical block inside protrude more deeply to the camera sensor. So, and now what we can do, we just can turn a little bit more the ring, a little bit more. You see it was in this position more or less, and you still can turn it. And normally I will not claim that it will fit all the lenses, but based on my experience, 60-70% of lenses HELIOS 44M, by turning this ring completely, screw it in, turning to the right like this, you just find this 1.1 millimeter that we need. It will allow us to protrude the rear block, the whole optical block inside the focusing, inside the lens body, more deeply into the camera. You can see how it moves. You see, it was in this position more or less, and we still can it make moving more. And this is position we will fix our ring now. Here in this position you put your ring after you have turned to the clockwise this brass ring. Then you just put your ring, and then you put these little screws on their places and you tighten them well. You tighten them very well. One, then two here, sometimes tricky to put little screws onto its place, but finally it will come. You tighten it very well. And the last one here. So this done. Then you just put this ring on its place. So it's fixed. Then you just put your front ring on its side, on its place. And you enjoy your lens on the camera. But there is another issue you need to check it up. So the distance from this position to mirror in Nikon cameras 9 millimeters. So you need to check if there is no more than 9 millimeters from outer rim of the rear lens block to the mounting flange. Otherwise your mirror will hit the back. It gives us 9.3 millimeters. So in this case, what I do, I remove the rear optical block and using turning latte I cut this outer rim. So we had 9.3 millimeters. So I will cut this outer rim at 0.4 millimeters in order to avoid that mirror of your Nikon camera hit the outer rim of rear lens block. So, and basically it's done. You just put your lens onto your Nikon camera and you enjoy the really great shots this old but very nice lens delivers. So in this video I just showed you how to make properly work this lens on Nikon cameras. Of course you can use some spacer rings and put them under the rear optical element. It will help also, the lens will focus, but image quality will not be the same. I'm selling this kind of lenses in my eBay store, so if you are interested in to buy already ready lens, already made, already checked, cleaned, lubricated, adjusted properly to your camera without any mirror hitting issues, so you're welcome. This is Retro Photo House. We are working for you. Thank you for your attention and goodbye.